John here. This is part 6 of the series on how to create a large 7-segment LEDs that you can 3D print. This section is about these walls between the segments, the intra-segment wiring path through here that we discussed in the prior part when we were worried about these access holes. So now we got to knock the walls out so wires can flow through here. And then we can print it out and start building our sign. I don't think we need this old code here. It's getting stale. Let's start by creating just a back segment for reference. One segment. Alright, we need to decide whether or not we want one or more of these walls removed when we make the back segment. Of course, the front always has all the walls. So this is an optional thing that we'll add to our segment, just like we did the wire hole, but we'll add a flag. Say, hey, I don't want a wire hole. I don't want this wall over here, that kind of logic. Okay, so how do we do this? Well, there's the raw segment. Then we can subtract out more items. So we'll add some more if I don't want the lower left, then remove it kind of logic in here. So we'll need some more flags in here, like lower left equals, I'm going to make this true, and I'm going to do this because I want this, when it's true the wall will be present, false will be the wall is removed. That will be the logic that I want to use for this thing, right? So lower left, upper left equals true, lower right equals true, upper right equals true. So these will all default to true. So I want all the walls in there, okay, and it didn't give me any errors, so at least I can add a bunch of variables here that I'm not using. Of course, now I just moved over the wire hole variable, so let's make sure that this is the one and only one case where we use that variable. Now, the scope rules of OpenSCAD are such that this makes sense. The wire hole keyword parameter in the segment module, which is this guy way over here, shall equal the wire hole variable that's currently in scope, which is mine up here. So that's what this means, all right? So that solves one of those problems there. We can test this out by saying true, really quick for testing. Or better yet, let's go up here and make it true here. Wire hole equals true in our segment. So clearly that's working correctly. Wire hole equals false. There you go. Okay, it's all good. All right, so by default, no wire holes, just like it was before. By default, we have all our walls, which is fine. We haven't written any code to remove them yet. Okay, so the API, the general interface of this is now in place, and we've set it up to be generally compatible. The front doesn't care. It will not create wire holes. It will not remove walls. So by default, the front will be fine. So what are we going to do then? Say if I do not want, say, lower left, I need to put a cube down here to remove that because I'm doing a difference here. Translate to where it needs to be, wherever that might be. Cube. Whatever size it needs to be. I happen to know, I think forward thinking, I'm pretty sure that these cubes should be centered. This will probably compile even though it's bad code because this is not, the not LL is itself false, so it hasn't executed this code. Let's not translate it. Let's just get the cube in place first. So how big does it need to be? Well, it needs to know, I need to know the size of the inside cap length, which is this here, provided you use the inside width for this variable right here. This was discussed in part 2. So I'm going to make this inside face length and hang on to it because all the cubes are the same size. So if I don't want the lower left, I'll create a cube whose X and Y dimensions are IFL. and whose Z dimension is got to be high enough to be able to remove that wall, which GZ is the full height of this segment, so that seems pretty reasonable. And let's call our segment and set LL equals false while testing. So I don't want the lower left wall. There we go. We come down to back. Well, I created a back, so I have to add all the same variables here to back to propagate them through. That all makes sense. No biggie. There we go. Lower left, upper left, da da da. And I also have to propagate them through to the call to the segment, much like wire hole. Since they're all named the same, they'll all be the same way. The wire hole will be. Okay. Now you can actually see there's the hole for the cube because we haven't moved it to the right spot yet. Lower left, upper left, lower right. Okay, that all makes sense. There we are. Now we have a little test case, and you can clearly see that there is a cube in there. It turns out it's this one. Let's put a marker on there so we can see what's going on. Indeed, it is this one. You can see that that cube, I centered it in X, Y, and Z. All right, so that makes sense that it got stuck there. You'll notice also that it did not remove the divider. You can see it inside there because the divider is added to the segment after this code is done. The divider, remember, is added up here, okay, after this. So this will not remove the divider even if I lift it up in the Z dimension, which I'm going to do anyway. Let's just for now move it up in. Where does this thing belong, right? Well, if it's GZ total height on its own, because it's centered, I wanted it centered in X, Y. I don't really want it centered in Z, but you got to do all three or none. So it's easier to center it in all three and then just say, well, I know that half it's down by this much. So now it's lifted up. It's flush now at the bottom. You can see it's actually now coincident. It's the surface of the cube is now coincident with the bottom, which is why it flashes like that. And clearly the divider's still there. Okay, so that's looking good. So now I only need to move it down and over here. I also need to rotate it in order to, this is lower left, so it's got to go over here. So it needs to be rotated 45 degrees in the Z-axis. Now it's looking pretty good. So we need to move it down here and then over there. So the center of the cube is right here probably. Well, yeah, once it's here, then it needs to move in this direction. So it actually needs to go further than half the inside length. And then it needs to move to the left enough to deal with this. So what I really want to do is move the center of that cube to this. And it turns out that's a pretty reasonable thing to do. So this is down inside length over 2 plus half this distance, which is a quarter of the inside width. So this is going to be, we have all that available to us. So this is, that's in Y. So I'm going to put this in parentheses. I'm going to go down IL over 2 plus IW over 4. And in the X, well, let's leave the X alone and just do the Y. So this is, I think, in the right spot. Vertically, it's not got to go to the left. So since it went down to this middle here, it needs to go over the same amount over there in order to line up. So that really needs to go negative IW over 4 in the X, at which point now it is right where we want it to be to knock that wall out, but it's actually too low because it's not going to clean through to the bottom, right? That's because GZ over 2 aligns the cube to the bottom of the Z-axis. We need to align the bottom of the cube to the bottom of the inside of this segment, which is at IZ We need to move it up the thickness of the face or the back of the segment, which is this guy. All right, now we're exactly where we want to be. That thing knocks out exactly what we want, and it won't interfere with the center divider because it's removed before the divider is added in the first place. So that thing is now removed, the lower left corner. And all we need to do now is repeat this. They're all going to be the same dimensions, but the signs will change as they move around. Kind of like what we did when we created the 7 segments. It turned out once we knew the right dimensions to use, the actual values were just based on changing their signs. So if we want lower left, we did that. For lower right, we're going to go down the same amount in Y, but instead of moving left in X, we're going to move to the right in X. In order to go to the upper left, this is a copy of the lower left code, we want to go what? Instead of negative Y, we're going to go positive Y and negative X. And then you're going to go to the upper right, which is all opposite. To the right, we need to have a positive X, and it's upper right, so that would be the positive Y. So I think this is probably okay. Obviously, we need to test it with our little test case up here, lower left. Let's change it to lower right. And clearly, that looks pretty good. All right. Upper left. That guy's gone. And he's aligned. He looks pretty nice. Okay. Upper right. Fine. All right. So that's how you knock out the walls you want to remove. Now, when we're creating the back, the 7-sided back, or remember by default all the walls are up. When we're calling the back logic here from back 7, now all we need to do is say whether we want to knock these things down. So it's this one. This is the center. The center you need to remove. Remember, it's rotated, so it's really like this. I want to remove the upper right and the lower left from this center piece. So I'm going to say upper right equals false. Lower, what did I say? Upper, geez. Upper right, lower left. Fine. Upper right, lower left equals false. So now when we render the middle one, we should see. Now I saw it leap a little bit. And I can see they're gone, but remember, there's 2 walls here that are being finagled. There's the wall on this segment, and there's the wall on the one up here. Both of those need to be removed. So you can see that this little part here was removed and cut out. All right, so that's correct on that one. This one looks good on this one. So you got to keep your wits about you. Which one got rotated? Which one got translated? All that fun stuff. So that's the center one. What's this guy doing here? This is the top one. So again, we need the upper left and the lower left need to be removed. Upper left, lower left. And if you can learn how to type, you're doing pretty good. So does that one come out right? Yes, there's this guy's gone. And is that guy gone? It looks skinny enough to be gone. Yeah, you can see that little edge right there. Okay, so that one's done. Once you get a few of these going, you'll be good. So let's do this guy over here. This one here only needs to remove this because no wires will ever flow between these two. So this is the upper right one. Which one's that? Would be positive offset in the Y and a positive in the X. So here's a positive X offset, and there's a positive Y offset right there. So and it's the one with the wire hole equals true, so we know that's the right one. So what do we want to do for that guy? That's upper left equals false. Order doesn't really matter on these keywords, but for some reason in my head I'm thinking about the walls before I think about the wire holes. So now that this guy here has his guy removed and this one over here is removed, that guy, now the wire path is clear. So when I'm running the segment here, the strip here, and the wires have to go around this corner, they can get there. So let's just go around down the horn. What's this one? That one's already done. This is the bottom one. So what does the bottom one need to have removed? He needs the upper right and the lower right need to be removed. Upper right is false. lower right equals false. Save it and preview. What do we got? That one's gone. That one's gone. Looks good. What's this guy? This is negative in the X, positive in the Y. That's this guy up here. He needs to have upper right and lower right removed. All right, now this is all opened up. All right, looks good. What's this one down here doing? This is the other guy that has the conditional hole, so that's clearly this lower left one here. He does not need this wall removed because no wires will go up this way. They come down and around like this. So he only needs the lower right removed. So I will say LR equals false. Oh, remember this one's also turn around 180 degrees right here. So this will be the opposite. I don't want lower left. I want upper, or lower right. I want upper left to be removed. Okay, whoopsie. That's fine. That's what we got to debug and test all these things. All right, that's looking good. This guy's done. That leaves us with the only one left must be the one over here, which is a positive X offset and a negative Y offset. So that makes sense that it's this one. He wants upper left and lower left removed. Upper left equals false. Lower left equals false. There we go. There's your wiring paths for your back. Done. All right, that's all we got to do to remove them. Well, I suppose we should test to make sure the front still works in case we messed something up. Because in the case of the front, none of the walls should be removed. And we can see no walls are removed. And there's no extra holes in there, so the front's still good. So the default values all work fine. So there's your wire paths, your inter-segment wire path access. And that should obviously work no matter how many strips we put in there. Go ahead and put 3 and so on. It's still the same arrangement. Remember, the odd number of strips need 2 holes. The even number of strips needs only 1 hole. And you even works for 1 strip. All right. Again, nice parameterized design. Once you figure out some of the details, then it's really easy to change this around and make bigger and little ones. So that's going to be pretty cool. So at this point, you probably could just move on, print, and use them just as they are. But I found that it was nice to have the fronts snap into the back, and then you could pop the front back off. The first set of these I made, I actually did make a sign with this exact design right here, and I just glued the fronts on. But not soon after that, something happened to one of the strips that needed to be replaced. I won't say what, but I had to replace some of the strips, and I had to open the thing back up. So snap-on face is a good idea. In the next section, the next part of the series, we'll talk about how to make the snap-on face.